documents by applying clustering algorithms. For example, clustering text documents using k-means. Naive Bayes is a basic technique for classification of text. It assumes that the probability of each attribute belongs to a given class value and is independent of all other attributes. The advantages of Naive Bayes classifier: it performs the task with limited CPU and memory. Therefore, it's very efficient. It's fast, as the model training time is very less. Naive Bayes is heavily used in sentiment analysis, email spam detection, categorization of documents, and language detection. Multinomial Naive Bayes is used when multiple occurrences of the words matter. Multinomial distribution normally requires integer feature counts. Let's take a quick look at the scikit multinomial NB model class. There are three major parameters in this class. Alpha. It's also known as a Laplace transform or smoothing parameter and is mainly used for categorical data. Fit prior. It indicates whether to learn class prior probabilities or not. If false, a uniform prior will be used, but as you notice, the default is true. Class prior. The default is none, but if specified, the prior class is adjusted according to the data. The next feature of sllearn we'll be looking into is grid search. We use a document classifier to predict the category of a document. To try predicting the outcome of a new document, we need to extract the features. A document classifier can have many parameters, and a grid approach helps to search the best parameters for model training and predicting the outcome accurately. When we create a model, it ends up with multiple parameters. It would be too tedious to run through each parameter and tweak it. In such cases, a grid search is useful. The whole dataset can be divided into multiple grids, like a chessboard, and a search can be run on entire grids or a selected combination of grids. So we use a grid search mechanism to perform an exhaustive search on the best parameters which affect the model. However, this approach has some constraint, such as the whole grid search process is subjected to availability of the CPU cores of the system. This is owing to the fact that there can be several parameters, and running an exhaustive search can impact the system performance by taking more of the CPU memory. So far, we have learned that there are three major steps for analyzing text data. 1. Vectorizer. This is a general process of converting a collection of text documents into a numerical feature vector. In vectorization, the documents are split into words or tokens, and each document is assigned a number. 2. Transformer. During transformation, you find the occurrence of each word in a document. This process is primarily used for feature extraction. 3. Classifier or model training. This is required for accurate predictions. A model uses training and testing datasets to optimize its overall performance. For example, different algorithms are used to classify text documents and find the sentiment analysis. This is where sllearn becomes more productive by creating the pipeline for the dataset. A pipeline is essentially a combination of these three steps. So using sllearn, pipeline can be created and we can train the model using a single command. We just need to put them all together in a single class and create a pipeline to operate on a given dataset. The main purpose of the pipeline is to assemble several steps that can be cross-validated, while setting different parameters. In this demo, we'll learn how to apply pipeline and grid search. Let's start by importing the required library: pandas, string, print, and time. Next, we'll get the spam data collection with the help of the pandas library. Here, the \t indicates that data in the spam dataset is tab separated or tab delimited, and sep function takes it as a parameter. Also, message is a feature which refers to the text present in the dataset. Response is the label or the category of the message. Let's view the first 5 records of the spam collection. The head method is used to view the topmost records in a dataset. Let's import scikit-learn specific libraries for text processing and creating the pipeline and performing the grid search. We will import countervectorizer to tokenize the document and convert the text into numeric values. Also, let's import tf-idf transformer for tf-idf transformation. Now, import sgd classifier from the linear model. This is to classify the message in the dataset. Next, import grid search from the sklearn grid search class to perform the grid search. Finally, import pipeline from pipeline class. Let's create a pipeline by instantiating the pipeline class and passing vectorize, transformed, and model classifier as argument. The statement you see here helps create the pipeline for the entire text processing. Now, let's define parameters for grid search. We are going to use the tf-idf parameter to weigh the terms present in the message. Next, let's create an object grid search and pass pipeline, parameters, jobs, and verbose as arguments. The grid search consumes a lot of memory, and injobs equals -1 instructs the process to use all CPUs while processing. We can print the parameters and run the grid search on the dataset for both the message and response after fitting them into the grid search object using the fit method. The grid search is a CPU-intensive process, and it takes a little time since it does an exhaustive search on the entire dataset on the past parameters. This brings us to the end of this demo, where you learned how to apply pipeline and grid search mechanism.